Welcome to This Is My Architecture. My name is Andrea, and I'm here with Saral from Snap. Hi, Saral. Welcome to the show.
Thanks for having me.
So what do you guys do?
So Snapchat is an app that hundreds of millions of people around the world use to communicate with their close friends. Our focus is on close friendships, and we enable the fastest way to communicate by building features like AR lenses, maps, Bitmoji, and Spotlight.
Awesome. So today we're going to talk about the platform, which resides on AWS. I'm super excited. And let's look at an end-to-end workflow using Snap, sending a snap using Snapchat. This must be massive scale. I mean, how many users do you have and how many snaps do you deal with on a daily basis?
Yeah, that's a great question. So we have over 300 million daily active users on the platform.
Okay, that's massive scale. Let's look at the life cycle. I'm a user, I'm using iOS, Android. What's the flow? What's the first thing that happens when I send a snap?
Right. The first thing which happens is the iOS app uses our gateway, which is an EKS service which we have built to talk to the media delivery service and send the snap to CloudFront and persist it in S3, just so that it's closer to the recipient when they need it.
I see. Okay, so runs on Elastic Kubernetes Service. How do you orchestrate this?
Right. So our MCS is the core orchestration service which we have. The next thing which the client does is, again, the client makes, once the client has persisted the media, it makes a request to the core orchestration service, which then checks the friend graph. The friend graph ensures that the sender actually has permissions to send the message to the recipient. Once the permissions check is done, then it actually persists all of the conversation metadata into our own database called SnapDB, which under the covers uses DynamoDB.
I see. So what made you choose to create your own SnapDB as a front end to DynamoDB?
Yeah, so we are talking about a lot of scale on DynamoDB, and we chose to build some higher level features ourselves, like transactions, TTL, as well as how to efficiently kind of deal with ephemeral data in our own layer. We also deal with incremental state synchronization so that we are not putting a lot of burden on DynamoDB, and it keeps our costs in control.
I see. So you're storing the metadata in DynamoDB, right? So what level of scale are we talking about here?
So we are talking about 400 terabytes of data, which we store in DynamoDB. And interestingly, we run nightly scans on DynamoDB, which run 2 billion rows per minute to kind of do various things on DynamoDB, including looking for friend suggestions or deleting ephemeral data as well. So we are very heavy users of DynamoDB.
Okay, so you do nightly scans just to make sure that it maintains the relationships and friends and everything.
Right.
Okay, so we talked about the send snap. What about the receiving end? What happens?
Right. So the most interesting part about receiving Snap is it is very latency sensitive, right? Your friend wants to get the message as soon as possible. So the first thing the messaging service does is it looks up a connection ID, a server ID from Elasticache to get access to the persistent connection which a server has to the Android client or to any clients in the world, so that we can quickly push a message to that client. So we look up the metadata from the Elasticache, we find the server which this client is already connected to, and through that gateway, we basically send the message to the recipient.
I see. And then you retrieve the data as well, the image or video through and chat information through S3.
Exactly. So that media ID was persisted all the way through to Elasticache as well as DynamoDB. So we use that media ID to kind of get the information from CloudFront.
Makes mostly sense. Now, this is massive scale. Like, can you give us some quantitative details of like what size cluster are you running? Just give us some numbers.
Yeah, we have over 900 EKS clusters running, and many of those clusters have over 1,000 plus instances, which makes this like a really heavy kind of service graph, essentially.
Makes perfect sense. And how do you keep this at the low cost, high performance? I think you mentioned latency is hugely important on the receiving side, but also the cost.
Yeah, for sure. Like latency, when we moved to this architecture, we were able to reduce the P50, the median latency of sending a snap by 24%, which is a huge business impact for us. Secondly, in terms of cost, because we use so much compute footprint, we are always looking at things like auto scaling as well as using the right instant types like Graviton to keep our compute costs low.
That's fantastic. This is interesting architecture because you're dealing with massive amount of data, and you're cleverly kind of coming up with innovative ways with, for example, SnapDB to reduce latency and really make that user experience better, and then use of Graviton and others to keep the cost low. So thanks for walking us through this architecture.
Thank you so much.
And thanks for watching This Is My Architecture.